So let's start by looking a little bit into the history of the research into visually grounded language learning. And The first paper I want to discuss briefly uh, was published in 2002 by Roy and Pentland, and it introduced a model called CEL, or Cross-Channel Early Lexical Learning. And it was followed up by a series of other papers with some refinements. So this was the language here was visually grounded. The inputs to the model were paired spoken utterances and images of objects. However, the modalities were collected separately and matched afterwards. So in this case, as far as I understand, the spoken utterances were extracted from a corpus of child-directed language, and then images of objects which appeared in these utterances were created separately and matched the utterances. And so the computational model was modular, and it was performing the following tasks. It would segment speech at word boundaries, it would form visual categories, and it would then associate the hypothesized words with these categories. In terms of the visual input, these are the types of objects or images of objects that were used. You can see that these are just a few different types of simple objects that would are likely to be uttered by parents or other caregivers interacting with children. And so the architecture consisted of two main components: two memory stores, short-term memory, which is a kind of buffer which it keeps recent input pairs for a few seconds, and then based on what's in this short-term memory, there is a what they call a recurrent short-term recurrence filter, which tries to extract pairs of uh, or speech segments which co-occur with shapes, and then these are then passed on to the long-term memory. And the long-term memory is another store, and in here these initial hypothesized pairs of inputs are further filtered using mutual information, and that's then what is left after this filtering makes up the lexicon that the model has learned. So let's have a look at the schematic of this model. So there are the two modalities. They're pre-processed in some way, as I will mention later. Then there is the short-term memory, which keeps the inputs. The short-term recurrence filter passes the ones which reliably co-occur with each other to the long-term memory store, which is then does further filtering based on mutual information, which is a way of quantifying how strongly associated two random variables are. One important thing to mention with regards to this model is that the utterances are actually pre-processed already before they are given to this cell model. They are represented as arrays of phoneme probabilities, and that is these are output by a recurrent neural network, which is pre-trained on a data set of phonetically transcribed speech known as TIMIT. In reality, this cell model does not work with the speech signal, but rather with phonetic symbols with associated probabilities. And so this is the recurrent neural network that they use to for creating this phonetic representation. You can see it's a pretty small type of network by current standards, but according to what they said, that was sufficient to give them the representation that they needed. The representations of objects were based on their shape, so there was no representation of anything else, like such as color or size. And this was also hardwired into the model in the sense that there are a number of pre-processing steps, such as foreground segmentation and object masking, and then this was all encoded in a shape histogram. So a shape histogram is a type of representation which is invariant to position, scale, and in-plane rotation. So the same object in different orientations or in different positions would be still have very similar shape histogram. So that was done also somehow separately outside of the model did not learn to do this. It was done in a hardwire way. And so the core of the model is this word learning, where which consists of the following items. So it would hypothesize word boundaries, phoneme boundaries, but subject to the constraint that these word candidates have to contain at least one vowel, which at least for English that makes it easier. And then the STM, the short-term memory store, would be search for segments which recur with the same with similar shapes. The similarity is determined by some distance, some metrics, some similarity or distance metrics, which they defined over phonemic and shape representations. And then these associations, which are stored in the long-term memory, are filtered via mutual information scoring, as I said before. So let's have a look at what the output of the model is, what it learns, and so they show here the contents of the long-term memory for one participant's data. And so you can see here in the different columns the phonetic transcription, the accuracy of the accuracy of the segmentation, and the semantic accuracy. So if you look, for example, on the first row, you see the phonetic transcription is shoe, and for this particular word, the segmentation accuracy, so it's correct, and the semantic accuracy is also correct. And if you look at the third row, we have a phonetic transcription which sounds like ruck. It in reality should be truck. So in here the segmentation accuracy is 0. There is an error in the sense that one of the phonemes is missing here. However, the semantics is correct. In general, what we see that this is a kind of a small scale lexicon, only less than 20 items here, and that brings me to the limitations of these experiments and of this model, and so there are a number of them relating to the visual inputs. Only single objects are used. Only their shape is being considered, so the color, size, or texture, that information is all ignored. As I already mentioned, the mechanisms for extracting and manipulating these shape representations are also hardwired and not learned. And regarding the speech inputs, as we saw, the vocabulary is very small, and the phonemic representations are pre-computed using a pre-trained network rather than starting from a waveform or a spectrogram, as ideally we perhaps would like. And also the data itself is not completely natural. It's the two modalities are corrected separately and then are paired heuristically.